So, in this video, we're going to talk about solving for an energy level. This is a question I made up, but in the grand scheme of things, right, solving for these questions, one of the energy levels, at least one, has to be given to you, along with, more importantly, the wavelength, right? So we're going to talk about how to solve this. Well, we know the Ryberg equation is equal to 1 over lambda, which is equal to, 109737331.6 meters inverse, that's 1 over meters, times 1 over n squared, final, minus 1 over n squared initial. So in this question, they're just asking us to solve for the initial energy level, which is the one on the right here. Right? By the way, this number could be made much more simpler, which is 1.097 times 10 to the 7th. But I just like to write a decimal. That's just me. So we know this is inverse meters, right? They've given us the wavelength in nanometers, so we got to convert nanometers to meters first. So let's see, 400.0 nanometers, right? Dimensional analysis, right? For every 1 meter, there's 10 to the 9th nanometers, right? Nanometers cancel out, and so final answer should be 4.000 times 10 to the negative 7 meters. So now that we've gotten that done, we just plug it in, right? 1 over lambda, which is the wavelength, 4.000 times 10 to the negative 7 is going to equal 1973731.6 meters inverse times 1. They're giving us the final energy level, right? 1 over 2 squared, right? Minus 1 over n squared. After that, we're just going to walk through the algebra now. So we divide 1 by 4.00. So let's do that math. Right? And we should get 25. 1, 2, 3, 4, 5 zeros. That's the answer of 1 divided by this number. Right? Equal 10,973,731.6 meters inverse. Alright, and this should be meters. I'm sorry guys, I'm messing up. It should be meters, 1 meters inverse rather, because that's 1 over meters, right? That's 1 over meters. Meters inverse. And let's do the math right here. 2 2's, that's square root, that's 2 times 2, right? Which is 4, so that's 1 over 4 minus 1 over n squared. And let's do the simple math right there. Right, now let's redo this stuff by just dividing 1 by 4. Right? Which equal 10,973,731.6 meters inverse times 0.25 minus 1 over n squared. I think we're just gonna write about this number right here. Meters inverse. Now we want to isolate n, because this is ultimately what we're solving for. So we could divide this whole thing by 10,973,731.6 meters inverse. And whatever we do to one side, we gotta do to both sides, right? You gotta do it over here. 31.6 meters inverse. So using meters inverse cancels out. That goes away. So we are left with 0.25 minus 1 over n squared. This divided by this should give us 73, 1.6. Should give us 0.227816. It should be 4 sig figs, right? And all we're left now to do is just minus 0.25 on both sides. 0.25, and that should give us on this side that should give us a negative 0.022183, which is equal now to just 1 over n squared, negative 1 over n squared in my head. Now we're trying to isolate n squared, so we just divide by n squared, right? Multiply rather, I'm starting on both sides. N squared. These cancels out, so what we're left with is negative 1 is going to equal to negative 0.022183 n squared, right? And all we just now got to do is just divide negative 0.022183 n squared. N squared. We do the one side, we do the both sides. Alright. And now n squared now is going to equal to n squared now is going to equal to 45.08. Remember, it's 4 sig figs. And you could review the sig figs, but it should be 4 sig figs. Now all we're left to do is just take the square root of both sides, and we get n is going to equal to 6.714. But remember, n has to be an integer. So all we got to do is just round up. So n is equal to 7.